Hi again, science students. We're going to continue our discussion of conservation of momentum in this video. In the previous video, there were a couple of examples. We did these ones here where we were looking at collision type situations. We had an elastic collision up the top where the two objects kind of bounce off one another, and an inelastic collision down below where the objects stick together. So in that video, I liken the first one to like two pool balls knocking into one another, and they tend to bounce off one another. And in the inelastic, I liken that to a couple of lumps of plasticine that collide, and they tend to stick together in one big blob. Now in this video, I want to do a calculation which involves an explosion and conservation of momentum rather than collision. Now don't get nervous. I can see that you'd be able to see these people standing here. We're not going to blow anyone up. With these explosive type examples, it's not just bombs going off or hand grenades or that sort of thing. We can also consider other objects that kind of explode, okay? And in this case, we've got two people who are standing on an ice skating rink, and they're stationary, and they push apart from one another. So two objects moving away in opposite directions is kind of like an explosion, and that's how we treat it, okay? So a very important thing about these explosion situations is that the objects beforehand begin at rest. All right, so these two people, Joe and Mary, are standing on an ice skating rink. Joe's a lot bigger than Mary, so it's probably a father and daughter who have gone ice skating, and they decide to do this thing where they push apart. All right, so what I want you to consider beforehand is what is the total momentum before they push apart, over on the left here. Now the answer to that is, because they're at rest, their momentum is zero. So the momentum before is equal to zero. And that's usually the way it works in an explosion situation. If they want to make things a little trickier for you, they might have an object that's moving before an explosion. I have seen those types of questions, but we'll start out with this one that's a little more gentle, and this is far more often the case that we start with an object at rest beforehand. So that means that the two of these people afterwards, if you consider them together, still have zero momentum. So P after is equal to 0 kilograms meters per second. But of course, as we see up here, Joe moves away with a velocity of 2 meters per second to the west, and Mary is probably going to be moving to the east, okay, as our calculations might show. And this can be confusing because you think, well, hang on, you said that beforehand they were at rest and they had zero momentum, okay, because their velocity is 0, right? Now, afterwards, they're both moving. How can they still have zero momentum? Well, separately they don't. Joe has momentum greater than 0 to the west, whereas Mary has momentum greater than 0 to the east. But if you combine the two, they'll cancel each other out. So separately they have momentum, but if they cancel each other's out if we consider them together. Okay, so I might just call Joe a -2 there, and let's set east as positive. Okay, so Joe's moving west, so his velocity will be negative. So that momentum afterwards is 0, and we're going to have the mass of Joe times the velocity of Joe plus the mass of Mary times the velocity of Mary. Okay, so Joe's mass is 75 kilos. We've said that east is positive, so he has negative velocity. The mass of Mary is 32, 32 kilograms, and her velocity is what we're trying to find. So I'll just call that VM for velocity of Mary from now on. Right. So you might want to pause the video at this stage and try this one on your own. See if you can get VM, velocity of Mary, to be the subject. Then I'll have a go at it. Okay, so velocity of Mary, this is what we should get. First off, I'm going to take this 75 by 2, negative 2, over the other side. Of course, that would make negative 150 altogether, right? So I'm just going to make that a positive 150, so 150. And then we've got this 32 here. That's multiplying on this side, so it'll divide on the other side. So that's the calculation or similar that we should get. So 150 divided by 32 is 4.6875. So if we go to 3 significant figures, that's 4.69. Now, because this is positive, Mary must be moving towards the east. Okay guys, so go and seek out some explosion type questions. I've put a few in the description for the video anyway, and see if you can master these.